Hello. Hey, welcome to another Blender Sushi live noting video recording. Thank you for tuning in. Today I will be exploring the idea of visualizing sound or audio or music. It's kind of a big topic. Actually, you ideally you want to understand a lot of concept and foundations, the basic foundations of procedural workflow before you jump into sound visualization. Basically, yeah, I if you Google music visualization and you get like hundreds or even thousands of ideas of how you can visualize music. I certainly cannot cover every single. I couldn't create every single visualization like this in one video tutorial. However, I will try to cover like a super basic ideas, because with a procedural or even generative art, you basically you basically try to visualize data using computer graphics. And so same thing with music. You want to convert the audio wave into numbers. Before then you can pipe in um, using plugins like add-on like animation nodes. You can visualize it in any way you like. The simplest one will be like just driving the scale or the position, um, rotation, probably just transforming the object. But if you start to get into detail and try to drive instancer, it can get pretty complex. Like let's see, have a look. The spiral thing is beautiful. Like this kind of thing. It's a paint being driven by audio. You probably have seen that the video in YouTube. And then we have this circle, and we have what else? You can use color as well, like a kind of hair visualization. It's kind of complex design, all kind of stuff. They're definitely for you to have a look for inspirations, or you can start doodling and start from the very basic. How do you usually visualize music? Like that's music visualizer kit. That's really cool. Um, I've been trying to do this using Maya, and then um, I think there's an add-on like a Maya plugin that kind of can read MIDI or wave, but Maya is too complicated to do this kind of thing. Houdini is actually much better. Houdini actually it's made for music visualization, but Houdini is kind of complex in itself, and even a book that's focusing on music visualization using Houdini is super complicated. Like a normal person can't understand it right away. But with Blender, you have it right there already. And maybe I'll just gonna close this because it slows down my computer. So let's switch to Blender. So this topic is kind of like a request from Jax Luke himself. He kind of mentioned, why don't you cover sound visualization using animation nodes? Yeah, I think I'll do it. Even though it might be super basic, but let's give it a try. Give it a go anyway. Let's try. Okay. Let's go into compositing. Let's save this right away. And sound, I have the file already. I just need to increase the version and save it. If you want to quickly make a visualization, there are actually a few templates you can use. I believe it's a sound equalizer, that's one, and a simple sound controller. Yeah. Basically, when thinking about audio, you have like you can think of it just like a single channel, and you have like the data value goes from the loudest to the softest sound, and that's just a single channel. Or with sound equalizer, you have multiple channels, kind of. In terms of wave, if you're using MIDI, you can have like 8, 16, or whatever number of sound channel that you can um, analyze the data with. Let's say you make your music using like iPad or iPhone, and the app allows you to create MIDI, or if you record it using your own sound recorder, if you separate the channel, you can have multiple channels that you can work with. That's actually much more ideal. But in our case, sometimes we just have like a music, a single wave, and we need to wave is already, if it's a wave file, it's already digitized, and you can kind of sample the lower frequency, medium, or high frequency. Anyway, I'll just stop talking and show you quickly how we do it. I believe Blender actually have like a sound. By default, it has this way to convert sound to wave to animation. But with animation nodes, it's so easy to do. And even you just first started using Blender and you install animation nodes and you want to visualize music, it's super easy. I'll show you. So you need to go to sound. There are 3 nodes. Let's just get it. Let's get evaluate sound, and then we have sound from sequences. Now sound from sequences, it's kind of okay, let's put that to the side first. So we have sound bake, evaluate sound, and sound from sequences. If we delete, so this guy, sound bake, will allow you to load a sound. If you don't have this and you just have the evaluate sound, it will, and you click on the plus, you will get the same thing. So that's the first thing you need to do. You need to load a new sound. I'll just pick up one of my old sound. It's I made it using Chuck. Chuck is actually a really good software from Stanford. It was created by Ge Wang at Stanford, and then if you're learning programming and you want to touch a little bit of music programming, you can use Chuck. Highly recommended. So I'll just get that. Okay, that's a sound. It gives you, okay, there's a low and high, attack and release. I don't know the frequency of the low, it must be 0. The heights 20,000. I don't know, but I will leave it at default. You play around with the number, and then we can simply bake it. You can bake it as a single, let's call it single channel, kind of single or multiple. If you think you want to use it to visualize like a multiple array of sound data, use the second one. That's going to be a little bit more complex, but it's and there's an option right here. So from the lowest frequency to the highest frequency, right? Okay, let's just deal with the single data first. Low, high, attack, release. I'm kind of vaguely familiar with this terminology. I'm a little bit of musician, but not really. I just like music and visualizing data. So, Anyway, we have this sound, and let's if you load the sound into Blender, I believe it goes into the sequencer. So I always switch to video editing, and then we have, okay, we have the sound right there. And back to animation notes. I believe if you want the sound to be baked from the sequences, you just do it from here and bake, let it know which one you want to bake. But we don't worry about that for now. We just want to see the sound right away. So we just bake the sound, and then you have this data all ready for you to be used inside animation nodes. It's really cool. So we can put this aside. Now the sound is, if we load the sound, as you can see, you have the name of this music file, and then it says single, and you have this single and equalizer type that you can choose. For now, we just worry about single, and we don't need to use loop. I believe if it's a single data, you don't need to have a loop, and you just want to visualize it. Object transform output. Let's see. First of all, debug. Debug is the first thing you want to check to visualize your data. That's the fastest way, and kind of it's more for like programmers type. It's give you like a text data, right? You have seen me doing this many times. And so let's debug. There's a debug loop. It's a debug drawer. Sometimes more useful. Let me now play back and see the music. So it's just kind of like a video game type of music. I use Chuck, like I said before. It's now, you can see there's a value happening. That's a good sign. The value is probably too small. If you check from, it goes from 0 to just around 0.5. So it's really tiny, but you can always remap it. So maybe we'll do that. Actually, let's visualize it different way. So we have our cube, maybe a little bit too boring, but it's okay. Strength is a floating value. As you can see, it's not a 3 value, it's just a single value. If you try to plug in into vector, there's a like converter from value to 3 value, from a single floating value to 3 value, which can be a vector. So now the sound is driving scale. It's a bit jumping around because my frame per second is very small, and then it's kind of lagging. You wonder, oh, okay, it's not really sync. You might wanna go to video editing, and then we try to AV sync it and frame dropping on. Audio scrubbing, don't worry. Back to compositing, let's try again. It's probably more in sync with the animation now. Yeah, it's much better. I wish my MacBook is faster. Hopefully I can upgrade it once I have enough money. So this scale, what else? Okay, the scaling at the moment, the sound is driving it. The wave sound data is driving the scale, but it might be kind of too small. You will always use this map range node. It's really handy. So you kind of guess, okay, the data that's coming in, the input is between 0 and 0.5, 0.5 probably, or 0.4, and then the output's going to be between 0 and 1, or 0 and 3, 0 and 2 or 3. So you can change the range of the data being interpolated. And once you do that, if you plug it in, now it's much bigger. This probably can be smoother if we use interpolation, probably back or bounce. Can't really see the effects, so just my computer is too slow. Anyway, if you use something like, of course you can use monkey, but not much of difference. You can use with the scaling, you don't want to scale it all in all directions like this. So you can of course use vector combine. So it's a vector into the vector, and then scale. Let's see, maybe we want to scale it just in the Z. So let's try that. There's another way to visualize this kind of thing. That's just a single value, right? It's not too interesting, but certainly super easy. That's the first thing. Like, it's really easy to do this using Blender and animation nodes. You will not find any 3D software that does it this simple and it's so clear. Like, perhaps you want to also visualize it using, let's see, text. Yeah, text might be a good idea. Wait, where's the text one? Okay, that's the text. Suzanne can go there. Text by default it's facing the Z axis, but we want to rotate it in X 90 degree. So it's our text. And since this is animation node, we also have text node. Luckily, with version 1.6, I think we have most of the useful node. It's quite complete. 1 or 2 years ago, animation nodes doesn't have all this much of text. I mean, all this much of nodes to work with. So with text, I believe we can just simply use object output. We just grab our text right there, and then if we create text and then type in hello, so it's corresponding to it right away. Value size. Value is a float, but if you try to plug it into text, there's a convert to text node created for you automatically. Super handy. So you have, now you're visualizing the sound data as numbers. It's just like that debug right there. And of course you can also control the size of text. Start with rewind. So the sound controlling text, that might be useful. Usually, like a complex data visualized as text is much more interesting. Anyway, that's another way you can visualize audio. What am I trying to do with Suzanne here? Okay, Suzanne, maybe I'll just make Suzanne goes ups and down using sound. Leave the scale. grab Suzanne. Okay, wait a minute. Okay, that should be 111. Okay, location, and then we have vector input. No, we need combine vector. Value will be the z-axis. Playback. So that's also easy, super easy to do using animation nodes in Blender. Location, rotation, scale. That's the simplest you can do. This the next one you can use is probably, you have seen me using the array modifier. So let's try that real quick. Mesh. Let's use cube again. Place it in the center. Array modifier. Array, and then we want it to have copy going up. So Z. Yeah, I have 3, count of 3, count of 4. Maybe give it a little bit of space like that and make it smaller. And we can drive the value of the count like that. Let's try attribute output. Just grab our object and then right click, copy data path. It's gonna be modifiers array count. Value has wrong type, so it's actually expecting an integer. But if we try to plug in the value anyway, it's kind of doing it. But again, we need to map the range. We know that our data is between 0 and 0.5. So it will convert the float into integer. Huh. It's not really clear what's going on there. So let's use debug. So it's just okay. So because I'm a little bit silly and I was using this 2 map range. Sorry about that. Map range. It's good to make mistakes. Value out 0.3 output. Yeah. Now plug that in. Okay, this is out. This is also, yeah, handy. But of course, a single channel data is not so fun, so you might want to use like a multiple data value. So let's try. Go back to our sound. Instead of using the first one, we're gonna use the second one. Bake equalizer data. Click there, and it will bake the. It will analyze the data and sampling the sound, and dependent on the frequency, it will kind of slice it into 10 different frequency, 10 or 9. Let's have a look. But we now can use the equalizer. And then that's kind of a bug, I think. It shouldn't give you double. Evaluate sound. Get our sound. equalizer, single and equalizer, and we can use equalizer now. There's this a frame, absolute, and offset. That's actually kind of a little bit more complex. It can give you like a multi-array of data. If you are kind of want to trace your object, you also play around with this frame offset. So instead of having just a single time value, it's allow playing around with absolute and offset will give you kind of like a multiple array of data. A little bit more complex. I think hopefully I can show you soon. Anyway, back to the sound. So we have now multiple sound. If you don't believe me, I'll debug the sound and see. Sometimes we debug. So you have like a list now. That means you have like a more than one data. Debug is useful, but there's a debug list in which you can see the data like that. Turn on the numbering. So it's 10 data. Play back and we can see the number. And with multiple data, normally you will think, okay, we can, let's hide this first. Let's use loop and try to drive lines using that loop. So with testing, select it, tap W and then loop through string. Now we actually can have we are working on each and every single data in the list, and so let's use icosphere now. G, just like before, we want to use object instancer, and then we'll tell the loop, okay, we need to put this object list inside the loop. So we create a new iterator, object list, this float, let's call it sound data. Object list, and then we get our icosphere. We can move it to the side. How many instances? We can just plug the strings into instance, and then it will convert it, and it knows how many copies it should create. So, but now our instance is all in one. So object transform output. First of all, we will place each and every object on a separate location. Like I will use the index vector combine vector. Okay, for locations, as we know, the index goes from 0 to the total number, so we can use that in the Z axis, so it goes up, so it makes something like that. File save, and then we're gonna drive the scale of each and every sphere using the sound data, but of course we want to remap it. Plug that to there, plug this to that. Okay, now we have everything working, but it's too big, so we just adjust the range. File, save. So we have our music driving the scale of each sphere. Sphere is probably not the most interesting, not in this case, I guess. If you use something like cube and scale the cube down, and let's load the cube. Okay, cube is probably more interesting. Scale it up, especially if we just drive the scale X, for example. Let's cut that, use another combine factor, and we will plug that in, and then this should drive the X, and scale this to 1. Increase the range. This kind of like a mirror kind of reflect kind of effect is always useful. So let's see. Let's touch a little bit of this offset thing. So with frame set to offset, I believe you don't have any like kind of optional data, like optional input or output you can play with. But with if you change this to change the frame to absolute, you have frame, and with frame, so that means you have control over each and every data that comes in. So you can have 10 different frame and then kind of delay each and every data coming in. So it's gonna be an array of 10. So a little bit more complicated. Let's see. So instead of having, if you want to play around with the frame absolute there, you need to put the evaluate sound inside. You actually have that in object transform input as well. So I think, and it's kind of hidden because you might accidentally, so you can make that into absolute. So this frame offset frame and frame absolute is for you to create kind of a multiple array of data. So you can, if you have like an animated object like that and you want to create a trace, there's an example at o.g.youtube channel. So it's OG YouTube channel. He made this example where you can animate an object and you can trace the object and leave the objects behind it. This is really a little bit more complicated. I will not touch that in this video. But for sound, basically you can have like a multiple array of sound. So instead of just a single data, and you can have multiple data and you can offset each and every data. Let's visualize it anyway. So if we cut this thing and cut that, make 10 instance, and get rid of this. So we have just objects goes in, and we have the strings right there. See right away, if you put evaluate sound inside, you need to use the get list element, and let's see if this actually works like that. And if we just plug in the frame, let's have a look at the debug. Let's debug the loop. Let's have a look at the data. Let's stop the sound for now. Seems like something is broken. Maybe I need to turn off. Oh yeah, okay. So it's actually working, but you can see now it has like lists of data. It's kind of like 10 array of lists instead of one. That's because we are using this frame absolute thing, and we are looping this node inside. We are using the evaluate sound inside a loop, so it creates a 10 different loop, 10 different array of data. Hope I'm saying that right. Get list of element. Let's cut this. So let's create another debug loop node. So with the frame there, you can use the index to kind of offset the list of data. Let's see if we use math, plug in the index, and then check the data now. Now see, you have 10 different array of data that you can use. So I believe we can, by selecting the index, so we have something that's more like a running wave of data. This is sometimes more interesting way to visualize data like this. So that's frame absolute for you, but we don't want to be too crazy with that. Maybe I'll show you one more way we can visualize data. Let's see, turn this back to offset. This should disappear when it's offset, I think. So let's just create evaluate sound. Okay, it's a single, no, it's gonna be multiple. Frame is gonna be offset. Sound is gonna be our equalizer, like that. So multiple strings. Create the iterator, so it's gonna be float list. Sound data sound data goes in there. Let's try to do one more thing. Try it with line. Instead of using all these objects, we're just gonna use animation node. Get rid of object list, so it sounds. So we're left with this. Just back to where we start with, just the sound and nothing else. Alright, let's do let's create a line for now. Line is gonna be the curve. Let's use line first. Okay, line. Okay, let's focus on line. Search line mesh. Line mesh is a generator. If you use this before, so if you want to output the object and the type mesh data is expecting, so you will need to create a new object, target object. It needs a mesh data, and you can't just plug this into there, so you need to have combine mesh, and you plug in the vertex location and edge indices. You have that. This is just a line with 2 points. I know it's 2 because the step is 2. So it's, in order to create a line, you need a minimum of 2 points. You might want to have 10 lines. 10 lines. That's because we have like it's a 10 different channel of data of the sound strings that's coming on from here. So I'll give it 10 for now. The wave can goes up, it doesn't matter. Normally you want to see wave go that way, so totally up to you. Maybe let's make it goes that way. Okay, X in X, so it's 10. Okay, if I go to edit mode, you can see it's 10 different points and it creates a line. Okay, so that's what we have outside of the loop, but we want to create a loop to kind of deform the lines to follow the sound. So what do? We just simply pipe in the vector into this guy. So input's gonna be vector list. We can just pipe that in. So now the data of the position of each vertex goes into the loop, and we can mess around with it, but we're gonna output it back. Yeah. So with our loop, we tell it, okay, we're gonna generate some vector output. So click on this guy, and the output's gonna be vector. So we have that dot and this output. And now, before we see anything, we're gonna mess around with the points position just in the Z axis. So we're gonna create a combine vector node. Combine vector goes in, and then we need a vector mask probably. No, we don't need vector mask. We just separate the vector. Let me explain this real quick. So we have the vector, which is the position of each point in the line that creates a line, and we're gonna separate it, and we're gonna combine it back and use that as the output. And with the X, we just leave it like that. And the Y also, we're just gonna leave it. But with the Z, we want to use the sound data, and we just gonna use math. So like that. We have the original data, and then we will use the sound data to disturb that point's position. And so now if we use this, the output vector, we can just pipe it in there, and let's have a look. And of course I forgot to use the remap, so I'll use that, plug that into this guy. So that's another way again to visualize your data using animation nodes. Let's save this. Let's see, I wonder if we can use skin modifier add skin data. Yeah, there's like maybe it's a bug, or they might need to do something with the animation developer dev probably need to look at this. So we kind of need a way to, let's say at the moment the skin modifier doesn't work, but if we actually duplicate the line and then we apply skin modifier, it actually works. There's a way around it. It's if you want to bake out your mesh, you can use the Blender own baking system. So this is quite important. Okay, let's suppose we have the line. I'm just gonna duplicate it like that. So it's just a simple line, and then I will export it out as OBJ and make sure that we keep the vertex order selected, and I'll call it line. Export. So I'm exporting the OBJ, and then I will also use, there's MDD baking. This is MDD kind of like point cast baking. I think it was originally from Lightwave. We can use this to bake out our animation. So let's try. How long is our song? $200. Okay, we're gonna bake out 200. We're gonna cache it into MDD format. So we have animation nodes driving our line. It's generating and driving the lines. So if I go to export, Lightwave, point cast, MDD, okay, sound, leave it like that, and just export it. Now we're gonna bring it back. Let's see. This line, okay, we get rid of skin modifier. This line doesn't have any animations. This is the animation node driven line. This is our copy, and we're gonna use the MDD mesh cast. Mesh cache modifier format, leave it at MDD. Let's get our MDD. Now you can see our animation, and you can use skin modifier. Yeah, that's how you can work around the limitation of animation node. So with this guy, we can of course control the skin, the size of the skin. This is skin modifier. If you first time saw this, don't be shocked. It's really cool. So you have that happening. Now you can render it out because it's actually a mesh, and you can smooth it, right? That's also a good trick to know. Another way is of course to turn this into curve. Instead of mesh, we can use like a spline. Let's have a look. Spline from edges. I guess that will work. Vertices goes in, edges indices goes in. We have our spline object output. Plug that into spline. Create a new target and increase the bevel. Okay, that's our line. So our line is not doesn't look so beautiful right here. It's segmented at this moment. Spline from edges is kind of broken, so you just look at the line and it create. It's a fast way to do this, but it's not the most correct way. You might want to create from points probably. Let's see, points from that vertex list and plug in spline. Point slightly better, also still not so beautiful, so you might wanna sample the line and let's try that. Hopefully it works. Yeah, it works. Uniform amount, probably 10. Start and end, start to end. Okay, that's cool. Okay, got it. Uniform resolution. Maybe resolution is better. Slightly better. Not the prettiest, but it's something. You can increase the resolution, of course. Or you can have something that's more like a ribbon. Not bevel. Extrude, that's what you want. Extrude. Yeah, the extrude gives you that. Interestingly, maybe there's a bug. It's not displaying there. Okay, so there you have it. You have all kinds of way you can visualize sound. I didn't touch the color in this case because it might be too much information for you. Let's check it out. What else can we do? Let's see. Should I show you some more, like instancing, multiple instance, and offset the sound? Let's see how long am I recording this. Oh well, I guess that's pretty much what I want to show you. So you learned today how you can use a single wave of sound, and how you can sample it into multiple wave of data, like array of data, and then you can visualize it in different way using curve, by using scaling, all sort of stuff. Hopefully this one is useful for you. Of course, sound visualization is huge. Definitely try to make your own way of visualizing data. It can be like a circular type of visualization, perhaps. That's also cool to do, and maybe it's more like that, or you can use I tried it the other day. Actually, I was using Blender Smoke and drive the I have like just a single sphere like that, and the sphere is being driven by animation nodes. It's really simple animation. However, the sphere is emitting smoke, like a colorful kind of smoke. That's actually I was gonna end this video here, but I think we can actually do the smoke simulation thing. Let's do that. Delete everything. We don't need that. We don't. Let's delete that guy. Delete this. We don't need this. We just back with just the sound. Okay, and we're just gonna use a single value. Okay, that's also a bug. A little bit. Sound bake, not sound bake. Sample. Nope. Go to sound. Evaluate sound. Okay, single. Sound. Single. Plug it in. Sound data. We don't want sound data. Okay, we don't need loop. So just a sound and map range. And then let's create an icosphere. G. Save this as a new file. And object transform. Grab our object. Gonna drive a position. Okay, we're gonna move it up and down. See, in the Z. And now with the sound wave, of course, you can use between 0 and maximum value, but you can also do it like this, between -5 and 5, so it's more like going down and up. Let's give it a try. So it's more like if you can actually use a dynamic pane. Wait a minute. Suddenly I have like a lot of ideas. Dynamic pane. Yeah, let's do that. So we have this guy. Maybe we want it to move in the X, kind of like that. Let's try. Why not? With the frame, probably it's too fast, so we need to multiply it, reduce it by 0.5, probably 0.2, 0.1. So we have our animation, the ball going wacky. Let's see, if we turn this into dynamic pane brush, and then we have like a mesh plane, put it in the center, increase it, scale it like that, rotate it in X for 90 degrees, scale it in X like that, and then turn this into dynamic pane canvas, and we might subdivide it. Subdivide symbol, put it above the dynamic pane, increase it, okay. Now we play back. Let's see. Hopefully this works as planned. We're gonna paint this guy. Gonna paint output, paint map, vertex. With vertex width, can we visualize it? Yep, that kind of doing it. Paint, use paint. The thing with a dynamic paint is, in order to visualize it on screen, we need like a lot of resolution. But you can see it happening anyway, so that's cool. But if you use if you sample it out, if you bake this, it won't do things like this, but it's gonna be like smooth. Yeah, you can use dynamic paint to visualize sound, to make it like a drawing. It's procedural. And one more thing, if you turn this into smoke emitter, let's see what happens if you do that. Smoke, so this guy is gonna be the flow. It's gonna output smoke. My computer is definitely super slow, and it wasn't made for this kind of simulation. but let's try. We need, with the smoke, we need some kind of domain, kind of like a box to contain our smoke. So that's gonna be our domain. And let's see if it's already working. And with the domain, we can have like 64 division, timescale, dissolve on, dissolve probably 60 is best. I tried it last night. Smoke cache. If the computer is too slow, it might you need to cache the smoke in order to visualize it, and before you actually render it out. What's cool in Blender is, of course, you have smoke, and you can have smoke color, and you can drive the smoke color using animation nodes, and subsampling, subframe sampling is important. If the movement of this ball is too fast, then you need to increase the sampling. So you have this smoke, you have that. Border collision open, collide all, leave it open. Maybe smoke adaptive domain, you can turn that on. It's gonna be faster for simulations. And smoke cache, point cache, open VDB can be probably better. You can export it to Houdini, I think. Bake all dynamics. Let's see if it works. So you can't see the smoke, unfortunately. Maybe it's my computer. Display JS multi-texture GLSL. Let's bake it. So it's baking. Let's see, the simulation frame start 1 and 250. It's baking out the point cache of the smoke. If you have a good computer, a faster computer with a good graphic card, you can see this in real time. Sometimes it might actually crash if I didn't delete the animation nodes, but let's have a look. I should have baked it as file. At the moment it's using memory. Let's wait. Okay, so it's actually showing it. So let me just delete that now. Now that we have the thing baked. So that can be a cool effect, but you have to tweak your simulation. See, it's kind of, now we are kind of using animation nodes to drive and to create the simulations. So yeah, so a lot of things you can do. Sometimes you use like a procedural approach to set up some kind of simulations. So before you start a simulation, you animate the objects procedurally, and then you pass it, and then you let the simulation do the rest. Obviously we need to, I think the smoke is racing too fast, but if we go back to the anyway, like you can try doing it yourself. Basically you know already a lot of techniques. The color can be driven using animation nodes, as well as all kind of smoke attributes. You can use animation nodes to control, probably perhaps with a object flow you can make it to emit more when the sound is loud. Give it a try and spend some time on it. Sound visualization is definitely a big topic. You can make a book just to talk about sound visualization and all kind of data visualizations. So hopefully you like this video, and Please subscribe to this YouTube channel, and I will try to make more videos.